Welcome. In this video I talk about string manipulation. There are lots of functions in the library. I cannot cover everything, but I can point you towards the right direction. We start with some tricks to generate strings. Here, for example, I start with a byte sequence. Like here, I happen to know that this is Unicode, but at first Rust cannot know this. It's just a sequence of 9 bytes. I use the library function from UTF-8 and give it a slice. At first I take the whole string. Note that this function returns an option, a result value. So either it's a proper string, which we know is UTF-8 formatted, or it's a UTF-8 error. And we use the debug notation to print whatever comes. So for example, if I run this, I get the string ABC, Ä, Ö, Ü. These are 3 umlauts. I happen to know having these UTF-8 byte sequences. Now imagine I would use only 6 here. That is, I leave out the 3 last bytes. So I would have an incomplete UTF-8 sequence. This compiles, but when it runs, it gives me an UTF-8 error. Compare this to this situation where we start with a UTF-8 string. Here, a string slice actually. I could use a toString and make a string either. It doesn't matter. But then I do some slicing. So that works, of course, beautifully if I include all the bytes. This. But if I just use fewer bytes than here, notice that the return value is always a string slice. So therefore, there is no possibility for an error. Therefore, it will run into a panic. That's a runtime panic because slicing doesn't work. So the library function we used before is the safe version, which can report an error. This is the one which just crashes the program when things go wrong. A similar problem arises with indexing. Here I have made a UTF-8 string in a string variable, and I try to access it with an index. Here I just take 4 as usize and try to index into a string. If I save this, the compiler immediately says the type string cannot be indexed because it wouldn't be clear whether we mean byte index or character index. And character index would be an expensive operation because nobody knows how long these characters actually are. So this index is simply not supported. What I can do as bytes, and then I can index the 4th byte. What I then, of course, get is a byte output. And so what we do here, we would see the first, or actually the second byte of the A here. And let's see what comes out if we run this. It's an A4 hexadecimal. If you really need to access the characters of a string, you can use the chars iterator and then the nth method to get the 3rd character. This here will reliably give you a character. Obviously, there's an option around it, because nth could return none if there is no 3 or 4 things in the iterator. So this should pick out the A. See? Yes, it does. So an iterator is usually more useful if you use it like this to iterate over all the characters. So as you can see here, this chars gives you an iterator, and then you can iterate with it and get the variable c bound to a character, and you can print the results. So here you see the single characters of the UTF-8 string. Let's now talk about string concatenation. If I reserve myself a mutable string variable with capacity 100, then I can append things like this here. S is equal to S plus, and then a string slice here. Now, notice that if T is actually a string itself, and I try this here, it doesn't work. So it doesn't compile here because the concatenation operator plus for strings needs a string slice as second argument and a string as first argument. So what I can do is I just take the ampersand T here for a string reference, And that works because the string reference is automatically coerced towards a string slice. Appending characters is done with push, and appending a string is done with push string, so that's the same as this plus over here, but you again need a string reference or string slice as argument here. You cannot just use the string. So let me run this. Indeed, I can append to the string. Let me point out with some small extension down here a curious thing. You know, we have move semantics by default in lots of places. And that's actually also true over here. So we use this here to append to the string in place. So what's behind this? If I do this here, I take a new string variable, u, and assign to it with s plus ampersand t. Notice that the value of s is moved into u here by definition. Therefore, I can no longer use s down here. So if I would remove the printing of s here, it compiles. But if I want to continue to use s, then I have to do something else. I have to use my new string variable and take a clone of s, which is then moved into u and concatenated with the string slice t. Then it works again. Having said that, you should notice that this notation, due to the move semantics, is very efficient, provided the string has enough capacity. I want to conclude the video by a short tour of what other string functions are available. For matching, we for example have the method starts with and ends with. Notice that again the argument is a string slice. The result is a bool and can here directly used in the if statement. Finding stuff. The argument to find is a so-called pattern. Pattern can be a string slice like this here, or it can be a character if we look for a character, or it can actually be a function. For example, like this char is uppercase method. Here I would find the first uppercase letter in the string, which would be that G over here. The result is always of type option usize. Usize is a byte index, and option because when it is not found, then it's none. Remember that we had the slicing problem where if we get it wrong, we can panic. Here is the safe variant for slicing. That's the get method. You give a range and then you try to get a slice, and so you get an optional slice. If you get none, then the slice was not on character boundaries as it should be, or was not valid UTF-8. And otherwise you get a sum of the string slice. Here, for example, you can split at a certain position. You get out two slices, namely for the two parts before and after this index. And then we have splitting. For example, here we split at white space, and this gives you an iterator over string slices. And if you call collect on the iterator, you can store things in a vector. Likewise, here we do line splitting with the lines method. And again, I collect into a set of strings by putting into a vector of string slices. Notice that all these string slices point into the same string as you start with. There's trimming to remove white space, back and forth, and lots of other variants. In the description page of the video, you'll find links to the excellent documentation. Let's just now see what this program does. Here we have starts with ABC, ends with. Here we have found at position 3 the string DEF. We have found at position 7 the character H. We have found at position 6 the first uppercase letter. We have safely sliced something. We have split at position 13. We have split into white space. We have split into lines. Notice the empty line down here. And we have trimmed a string like here. Let's look at this line example. I intentionally put 2 new line characters at the end of the string, therefore I get the empty line here as the last argument. We have already reached the end of this video in the sense that I want to keep things short. I cannot have possibly covered everything you can do with string manipulation, but it gives you a start, it gives you something to look up, and in the accompanying web page I have linked documentation so that you can look for more. See you in the next one.